Hello class, today we're in chapter 3, lesson 6. We're going to be covering division of integers. We have a cartoon here. And for my next trick, I will saw the king in half, and the king is laying there in the box, and then he's sawing away, and a person in the crowd says, I can never figure out how they do this. Well, if any of you have seen this, basically what they do is it's not really the whole body that goes across. They make the body sort of sit in a position where you don't see the legs, and the legs sticking out on the other end really aren't the legs, so they're never really sawing anyone in half. Now, it isn't any trick to divide a number in half, even if the number is negative. Now, the figure below illustrates the number -10 divided in half. The solid circles represent antiparticles. So here's a point where these solid circles really come in handy because we're able to see a negative number. And as they show, they have here, let's see, 1, 2, 3, 4, and 5. And that's 6, 7, 8, 9, and 10. And similarly, if these were positive, we would represent them with just these circles. And if you were to divide them, you could divide both, right? Okay, so let's divide the first one. Well, let's divide the second one, the positive. We've done that before. So it would be right here in the middle, and that would give us 5, positive 5 on each side. If we divided the negative ones, we would divide it in half, and that would give us -5, right? -5 on each side. Okay, and when you add -5 plus -5, you get -10. Now, if a group of -10 circles divided in half each contains -5 circles, dividing a number in half is equivalent to dividing it by 2. Okay, so we have -10, and we're going to divide that by 2. Now the question is, what is our answer? Well, we already figured that out to be -5. Okay, because division has a meaning in terms of multiplication, it is possible to find the answer to the problem -10 divided by 2 without thinking of circles at all. And we do this, again, just because we understand the relationship between multiplication and division. And knowing that relationship, we think in our head, we simply ask, what number must be multiplied by 2 to give -10? And we know that the number is -5. Okay, we would multiply these two numbers together, and that would give us the answer here. Okay, and that's how we view division in terms of its relationship to multiplication. I like to call them cousins. They're probably more like brothers and sisters because they're just so connected. And it's going to be very important for us to feel comfortable with division, not necessarily in the terms of like dividing big numbers like you may have done in the past, but in terms of using this bar over here, this fraction bar, and seeing that these two are being divided, but understanding the relationship they also have when it comes to multiplication. So let's read on. Here's another division problem that includes a negative number. What is 12 divided by -3? Okay, 12 divided by -3. All right. Now, we can't answer this by drawing a figure because there's no way to divide 12 circle into -3 groups. If we tried to do the same thing that we were doing up here, we might run into a problem. We say, well, how do I divide by -3? Does that even make sense? And you may have a problem with it because you're saying, well, if I'm dividing by 2, what would -2 be? Well, let's just read on. And this is why multiplication is very important. And that's why a lot of times these illustrations, as I've mentioned in our class, that these illustrations of circles and particles and all these different things, they tend to have very limited application both in the numbers and also in terms of certain functions of math, but they're very useful to at least give you a visual representation, as we were able to see -10 divided by 2, so we can understand that, yeah, you could take -10 particles and divide it by 2 and we'll have -5 on each side. But again, we start running into a problem when we're dividing by negative. But we'll have to set aside that illustration then and understand that its limits do not allow us to see these things what they really are. So let's go back here and say, thinking in terms of multiplication, however, the answer is obvious. The answer to the problem, 12 divided by negative 3, is the number that can be multiplied by negative 3 to give 12. So if we follow this same example over here, and we multiplied this by the answer, we say, well, what will we multiply by negative 3 to get positive 12? Now we know that we must multiply two negatives, so the answer must be negative, right? And what number do we multiply by 3 to get 12? Well, the answer is 4. So our answer is negative 4, and that is when we multiply 12 by negative 3. Each of the two division problems that we have considered includes one negative number. Now, what happens when both numbers are negative? For example, what if negative 20 is divided by negative 4? So let's do that over here. Negative 20 divided by negative 4. Now, we know we could do our negative 20 circles, but still we're sitting here with this dividing by negative, and it just doesn't relate to this visual illustration that we've used. Now, but we can always go back to the kinship that we have between division and multiplication, as I said, and we can see, well, what do I have to do? Well, what happens when both are negative? It's a number that must be multiplied by negative 4 to give negative 20. So first I think, well, for me to get a negative result, and I'm multiplying this one by a number here, this one's already negative, so this one must be positive. Okay. Now the question is, what do I multiply by 4 to get 20? And the answer is 5. Okay. So we can see negative 4 times positive 5 is equal to negative 20. So we can start seeing a pattern here, similar to what we saw before with math. And you may notice, looking at the top of page 136, you may have noticed from these examples that every division problem has a corresponding multiplication problem. The signs of quotients of positive and negative numbers are like those of products. The quotient of a positive and a negative number is always negative. All right, so we have a positive over here and a negative, and the answer is going to be negative, right? And the quotient of two negative numbers is always positive. So we have negative and negative. Oh, excuse me. Made that little arrow the wrong way. So we have two negatives, and they're going to yield a positive result that we have over here. So, and again, here we just have negative over a positive, so we can say negative over a positive is going to yield a negative, right? Positive over a negative is going to yield a negative result, right? And this is actually a fraction here. It looks like a negative. And lastly, we have a negative divided by a negative, and that's going to yield a positive result. And again, we prove that using multiplication, because we can determine, let's say, the answer of a number divided by another number by simply thinking, well, the number that you're dividing by, well, what do you multiply by to get that same number? And again, we just simply follow those multiplication rules that we've learned. And here we have positive times a negative. Well, that's a negative. Negative times a negative, that's a positive. Negative times a positive, that's a negative. So we just need to feel very comfortable. And I'll go back and just remind you that whenever you see positive and positive, all right, when two things are positive and positive, they're going to yield a positive, right? And whether we're dividing or multiplying, in this case, we were showing down, well, we didn't do that one here at the end. So let's just say positive over positive is going to be a positive. And we're used to doing this, okay? This almost goes without saying. When we have a negative and a positive, or excuse me, let me just go back to our negative result. So negative, whether we're multiplying, whether we're dividing, as we are here, okay? We have here, and again, the first one was here. Over here, I'm simply doing the multiplication side of it, and that yields a positive. So when you put two together, it's always positive. Two are the same. When you get two different ones, okay, and well, you get a negative. And when you go the other way, you get the same thing. Now, maybe something very simple I could use as an illustration. We know how cats and dogs get along, and for the most part, they really don't. But they do if you train them well. But in let's just say you have a cat that meets a dog, and neither are used to each other. Yeah, what's going to happen? Well, you put two dogs together, and you might get the same thing. But ultimately, they kind of just walk around and they sniff each other, and they start kind of getting to know each other. And cats tend to be the same. I mean, they kind of figure out who they are, but they see that they're another cat. So you generally might get a positive result. Again, that's not proven. It's not always going to happen because some dogs are just more aggressive. But again, just trying to use this as an example maybe to help you remember. But now when you put a dog and a cat together, okay, you're generally going to get a negative result. And the same with a cat and a dog or dog and a cat either way. So maybe you can kind of think of things that way in terms of the difference between, say, a dog and a cat. Again, please do not try this at home. We do not guarantee you the results of putting two dogs together yield a positive result, and same with cats. But I think you kind of get a picture of what we're trying to illustrate here. So that's the end of this lesson.